voltage regulation. In the earlier video we showed by using 7812. Now we are using 7912. This is negative voltage regulation. So we have to apply negative voltage here. So this is what we are doing. Negative of the power supply is given to the positive of the terminal. That's why we are interchanging the power supply nodes, and it will turn as negative voltage power supply. Okay. Now we are connecting IC, input to input connection. Input is in this IC, it is the first pin. In this IC it is middle pin. So output to output, ground to ground. And now we are checking, first of all, without load we have to check voltage V in and V out. So I'm not using any load or any ammeter in the circuit, just we are checking V input and V output. So this is what V in, V out. So I am applying the voltage, say 2.5. Here it is 2.5, it is 0. V in, V out. These are all negative values. For analog we have changed it out. If you want, we can. If you are using multimeter, then you can easily find the negative reading. Or else any digital multimeter, the digital meters also you can see it show you negative readings. So 5 volts, it's 4 volts. V in 5 volts, V out 4 volts. So V out is 5 volts, it is 6 volts. Now it is 7.5, 6 volts, 10 volts, it is 8 volts here. So this is a unregulated voltage, this is regulated voltage. Both are in negative power supply. This is also negative voltage, this is also negative voltage. Okay, this is V in, V out. Now we are applying load and seeing the connection. Without ammeter, just applying the load and seeing V in, V out. So 2.5, still 0. When you apply the load, it will be lower current. Same reading you have to note down the readings. For 4 volts 2.5, 5 volts 4 volts, 7.5 it's 6 volts, 10 volts it is 7.8. so this is V in, V out with respect to load. Now we are checking the third tabular form by using ammeter in the circuit and applying load. Without applying the RL load, we are checking 3 meters, that is V in, V out and current meter. So same steps you have to note down. 2.5 volts, still 0. Sorry, the current is in negative direction, no? So this is it will come. So 2.5. See, now current started, even the voltage output also started at 2.5 volts. 10 milliampere, nearly 0.75 volts, 2.5 volts V in. So you can see there is a direct current coming from the IC. So from 10 milliampere it is jumping to, so you can even slowly you can note down for graph purpose, 20 milliamps 1 volt 2.5 volt, 30 milliamps 2.5 volts, that is 4 volts, 40 milliamps 2.8 and it is 4.8, 60 milliamps 5 volt 5.5 and it is 7 volts. So like that you have to note down the reading until 10 volts. Okay, similar thing applying the load resistance also you can do. I'll show you like around approximately around 400 volts, 400 ohms. So applying the load resistance by using the knob, even you can measure it in the multimeter how much resistance were applied. So these two are the load resistance we applied in the circuit. In with respect to multimeter, we have to note down the readings. So I am applying some load here and applying voltage and taking the same tabular form, repeating the same steps earlier, V in, V out and current. When you apply load, some voltage drop will be there and even the current drop will be there. Initially the current was around 80 milliamperes, now it is only 30 milliamperes. So there will be a current drop when you apply any load. If you can even see by I am varying the load, see the current decreases. If I like not apply any load, it is 80 milliampere. There will be slight change in the voltages as well when you apply load, because load will resistance will eat the V is equal to IR. So similar form is applied here. Okay, thank you.